All right, geometry. So we're going back to trigonometry, specifically solving right triangles. Previously, I was giving you guys a calculator. However, California standards and the SAT always like problems where you've got the special right triangles, the 45, 45, 90, and the 30, 60, 90. So if we go back to the 45, 45, 90, every 45, 45, 90 follows this miniature model where the legs are 1, and the hypotenuse is the square root of 2. You can check your work by doing 1 squared plus 1 squared equals the square of radical 2. So the square of radical 2 is obviously 2. 1 squared plus 1 squared is 1 plus 1, which is 2. So that checks out. That being said, every 45, 45, 90 triangle looks like this and has these exact same cosine and sine ratios. So if I take a look at the cosine of 45 degrees, the cosine of 45 degrees is adjacent over hypotenuse, or 1 over radical 2. And how exciting, if I take the opposite over the hypotenuse for the 45 degree angle, the opposite of 45 degrees is 1, the hypotenuse of the right triangle is radical 2. So, a little tip, the cosine of 45 degrees is 1 over the square root of 2. The sine of 45 degrees is 1 over the square root of 2. And a little hint, the legs of the 45 degree angle are congruent. So keep that in mind. It's just I can't write congruent. There we go. So that's my big hint, is if you know it's a 45, 45, 90 triangle, then the legs are congruent. Shh, I'm not supposed to tell you that. Anyway, looking at the 30, 60, 90, every right triangle that's 30, 60, 90 looks like this. The 30 degree angle has an opposite side that is half of the length of the hypotenuse. So if we take a look at this, what's the sine of 30 degrees? Opposite over hypotenuse, the sine of 30 degrees is 1/2. Okay? And the cosine of 30 degrees is adjacent over hypotenuse, or radical 3 over 2. Now let's look at the 60 degree angle. Let's take a look at the sine of 60 degrees. Opposite over hypotenuse. The sine of 60 degrees is the square root of 3 over 2. And the cosine of 60 degrees is 1 over 2. So the reason why I'm telling you this is going to be a big helpful hint. In fact, I'm using 2 notebooks because I'm going to keep this open, because I like these little formulas. So my hint over here, remember, it kind of relates to the sine of it relates to the 30 degree angle. The opposite side of the 30 degree angle is always half of the length of the hypotenuse. And vice versa. The hypotenuse is always double the opposite side of the 30 degree angle. So keep this on the side. If you want to take a screenshot of this, or if you want to keep this on the side, like I'm going to do for each of my problems, I'm going to reference this for 8 of the problems today. Okay? Moving on to problem number 1. Let me put this notebook on top. So what does it look like I got? So I've got a right triangle, specifically a 30, 60, 90 triangle. I know the hypotenuse. I'm trying to solve for the legs, the x and the y. So it doesn't matter which order you choose. So let's use our trig ratios appropriately. So let's say I want to solve for y. So specifically, remember that in, I'm just going to use my 30-degree angle for these problems just for today. We're going to be flexible throughout the course of the unit, but let's just say I'm just going to focus on the 30-degree angle today, just to ease into it. So if I've got 30 degrees, I want to solve for y. What side length do I know? Well, y and 8 are the side lengths I'm going to focus on. Y is the opposite side. 8 is the hypotenuse. So that's in my thoughts. Little thought bubble right there. So what that being said is I'm going to use opposite over hypotenuse, or the sine of 30 degrees is equal to y over 8. Now I'm going to go back to my diagram and know that the sine of 30 degrees is 1/2. So if the sine of 30 degrees is 1/2, now I've got a proportion. 1 over 2 is equal to y over 8. Do you guys remember how to solve a proportion? Cross multiply. So now I've got 2 times y is equal to 1 times 8, or 2y is equal to 8. Now I'm going to solve for y by dividing both sides of the equation by 2. Y is equal to 4. So now that I know that this part is 4, I've got 8, I've got 4, I've got x. I don't want to take away the, not the quadratic formula, the Pythagorean theorem. I'm not going to take away the Pythagorean theorem from you. In fact, I want you guys to remember the Pythagorean theorem. But just to get in the habit of learning trig, okay, let's just say I use trig ratios here. So solve for x. So once again, I'm going to look at my 30-degree angle. Specifically, let's say I use 8 and x. So if I look at 30 degrees and I say x and 8 are in my thoughts, that's my little thought bubble. Yes, I should be an artist. No, I'm just kidding, I'm a terrible artist. So if I look at my 30-degree angle, x is my adjacent side, 8 is my hypotenuse. Which trig ratio involves an adjacent and a hypotenuse? Right. I'm going to use the cosine ratio. So the cosine of 30 degrees is equal to x over 8. Therefore, I'm going to look at my cosine of 30 degrees formula. The cosine of 30 degrees is radical 3 over 2. So now I'm going to plug in radical 3 over 2 goes in for my cosine ratio. Cosine of 30 degrees is proportional to x over 8. Now I'm going to cross multiply. Where's my pencil? There's my pencil. So I'm going to cross multiply. I get 2 times x is equal to 8 times radical 3. So if I divide both sides of the equation by 2, I get x is equal to 8 over 2, which is 4 radical 3. So I've got 4 radical 3 here and 4 here. You can check your work with the Pythagorean theorem. Okay, see if we can do another one. Let's say you can do this independently. The hypotenuse is 20. It's a 30, 60, 90 triangle. Solve for x and y. Okay, pause the video. You can do this independently. I'm gonna encourage your flexibility. I'm gonna play with 60 this time. Okay, so let's say I want to solve for y. Actually, you know what? Let's solve for x first. Let's go alphabetical order. So let's say I want to solve for x. That's not a straight line, but you know what I mean. It's whatever. Anyway, so let's say I look at my 60-degree angle and I want to solve for x. I know that x is a side length that I care about, and I know 20 is a side that I know. So now let's do x. What is the side length x compared to the 60-degree angle? It's the opposite side. And 20 is the hypotenuse. Which trig ratio involves an opposite and a hypotenuse? Right, the sine ratio. So the sine of 60 degrees is proportional to the opposite over hypotenuse, x over 20. So if I put this in black, I'm going to look at my sine of 60 degrees formula. What do you know? The sine of 60 degrees is radical 3 over 2. So if I've got radical 3 over 2 is proportional to x over 20, I'm going to cross multiply. Now I've got 2x is equal to 20 radical 3. Now I want to solve for x. So if I divide both sides by 2, I get x is equal to 20 divided by 2 is 10, and I've got radical 3. So I've got x is equal to 10 radical 3. Now, let's solve for y. Okay, let's say I use my 60-degree angle yet again. So let's say I want to solve for y, and I want to use my 20 side length. Y is the adjacent side of 60 degrees, and 20 is the hypotenuse. What trig ratio involves an adjacent and a hypotenuse? Cosine. So the cosine of 60 degrees is proportional to y over 20. Now I'm going to look at my cosine of 60 degrees formula. The cosine of 60 degrees is 1/2, or 1 over 2. Now I'm going to get my pen. So 1/2 is proportional to y over 20. I'm going to cross multiply now. And now I've got 2 times y, or 2y, is equal to 1 times 20. So 2y equals 20. I'm going to divide both sides of the equation by 2. And that gets me y is equal to 10. So therefore, I'm going to put 10 here and 10 radical 3 here. You can check your work with the Pythagorean theorem. 10 squared plus the square of 10 radical 3 is equal to 20 squared. So I'm going to do that right here. I didn't do that with the other problem. So 10 squared plus 10 radical 3 quantity squared should be equal to 20 squared. Well, 10 squared is equal to 100. 10 radical 3 squared. So that'd be 10 squared, which is 100. Radical 3 is going to be 3. and 20 squared is 400. 100 plus 300 is equal to 400. Hooray. So even with the trig functions, the Pythagorean theorem is still your number one option. Okay. I'm looking at the clock and I want to give you guys a breather, so I'm gonna do only 30, 60, and 90s today. Okay. So let's see. This one's a little bit different. So I've got 30 degrees, 30, 60, 90. I only know one of the legs. I don't know the hypotenuse. So you pick in your own work. What do you want to solve for first, B or C? Well, it doesn't matter because you're still going to use trig functions anyway. So, but remember my little hints. If you go to the 30, 60, 90 triangle, remember that the opposite side of the 30-degree angle is always half of the hypotenuse. Or if you want to flip it around, the hypotenuse is always double the hypotenuse is always double the opposite side of the 30-degree angle. What I mean by this is, look at this triangle. I'm given the opposite side of 30 degrees. It's 15. If you know the answer, go for it. I love it. I love that you can read it. So let's say I want to solve for C. So if I look at my 30-degree angle, I'm going to look at 15, and I'm going to look at C. Specifically, 15 is the opposite side, and C is the hypotenuse of the triangle. What trig ratio is going to let me use opposite and hypotenuse? The sine. So the 30-degree angle, the sine of 30 degrees is 15 over C. I'm going to look at the sine of 30 degrees in my formulas. The sine of 30 degrees is 1/2. So now I'm going to make a proportion where 1/2 is proportional to 15 over C. And now I'm going to cross multiply. Oh, this is pretty. So now I've got 1C is equal to 2 times 15. Well, 1C is just C. And 2 times 15 is 30. And if you read that all along, I am so proud of you. The opposite side of 30 degrees should be half the size of the hypotenuse. So therefore, we just double the opposite side of the 30-degree angle, and we get C equals 30. See, I wish I was taught that when I was in geometry. Instead, I had to do these the long way. Okay, so solve for C, that is correct. So let us solve for B. Okay. So if I know that this is going to be 30 now, make that a little bit light. So there's two ways I could go about this. I'm going to show it in both ways. So let's say I use it with trig. Let's say I could pick either the 30-degree angle or the 60-degree angle, and I want to solve for B. I could say 30 degrees, 15, and B. So if I look at my 30-degree angle, 15 is what? It's the opposite side. What is B compared to the 30-degree angle? The adjacent. So if 15 is the opposite side and B is the adjacent side, soh kah toa, which trig ratio is going to let me use opposite and adjacent? The tangent. So the tangent of 30 degrees, actually, you know what? So let's see, I'm trying to think. Actually, you know what? I've got a better idea. Why don't I use the 30-degree angle? The side length of 30. So if I've got 30 and I want to solve for B, remember that 30 is the hypotenuse and b is the adjacent. Once again, I'm saying you can use tangent. I'm just trying to use the formulas that were given. But you can use tangent. Sorry about that. Anyway, so adjacent over hypotenuse, don't get fooled. The cosine of 30 degrees is proportional to b over 30. So I'm going to look at the cosine of 30 degrees, and that is radical 3 over 2. So radical 3 over 2 is equal to b over 30. I'm going to cross multiply. So I get 2b, or not 2b. 2b is equal to 30 radical 3. And I'm going to divide both sides by 2, and therefore b is equal to 15 radical 3. Okay? And I was going to show you the Pythagorean theorem. So let's say you knew that you had 15 and 30, and you wanted to solve for b. Well, remember that 15 squared plus b squared is equal to 30 squared. So then do the Pythagorean theorem, and you'll still get the same result. Okay? I'm going to do one more, and we'll call it a day. Okay, so let's say we've got 30 degrees, 60 degrees, 90 degrees. This time I'm giving you the opposite side of the 60-degree angle. Solve for A and C using trigonometry. So there's a variety of ways you could do this. This time I am going to use the Pythagorean theorem. So once again, I've got, let's just say I'm going to stick with the 30-degree angle. And let's say I want to solve for C. So if I look at the 30-degree angle, I've got 22 and C. 22 is the adjacent side, and C is the hypotenuse. Which trig ratio is going to let me use an adjacent and a hypotenuse? The cosine. So the cosine of 30 degrees is equal to 22 over C. And if I go back to my cosine of 30 degrees, that's going to be equal to radical 3 over 2. I'm going to cross multiply. And that's going to be radical 3c is equal to 2 times 22, which is 44. So then radical 3c is equal to 44. And if I divide both sides by the square root of 3, c is equal to 44 over the square root of 3. Okay, so that's going to be 44 over the square root of 3. Okay. Now then, if I were to look at the 30-degree angle and I want to solve for A now, actually, you know what? Let's see, what options can I do with this problem? Well, you know what? I'm going to use A and 44 over radical 3, because you know what? If I look at my 30-degree angle, see, sometimes this takes a little bit of thought process even for me. I like the 30-degree angle because A is the opposite side, and I like the hypotenuse, which is 44 over radical 3. That is my hypotenuse. Now I got this, because if I'm going to use the opposite over hypotenuse, or the sine ratio of 30 degrees, so now I've got A over 44 over radical 3. Well, it's a bit complicated, but I can simplify that by moving the radical 3 up on top. So I've got radical 3a over 44, because if I divide a divide, that flips to the top. Sine of 30 degrees is equal to 1/2. Now I'm going to cross multiply. So now I've got 2 radical 3a is equal to 1 times 44. And if I divide both sides by 2 radical 3, a is equal to 44 divided by 2, which is 22. And that, sorry, a is equal to 22 over the square root of 3. And it kind of makes sense too, because if this is 44 over the square root of 3, then the opposite side of the 30-degree angle needs to be 22 over the square root of 3. That makes sense. All right, so we're going to cut it off here, and we're going to do 45, 45, 90s on the next lesson.